Hello, my dear students and listeners and viewers at home. This is St. Charles College online teaching. I'm here to present the subject, basic technology. And the topic we have today is energy, work, force, and power. My name is Kajetan C.U.J. Onwuegbusi, your teacher. Specific objectives. At the end of the lesson, you should be able to define energy, work, and power. Number two, you state the units of energy, work, force, and power. Number three, you list the major forms of energy and define them. Number four, you do some calculations involving work, force, energy, and power. Concept of energy and work. Energy is the ability to do work. To be able to perform any work, one requires energy. Work is defined as force applied through a distance. In other words, you say that work is equal to force times distance. Definition of force. Force is an act which changes the position or state of a body or an object. We apply force by using the energy we possess to push, pull, or lift a load in order to change its location. Therefore, we require force in order to do any work. Forms of energy. The major forms of energy we have are mechanical energy, chemical energy, heat energy, electrical energy, light energy, nuclear energy, and sound energy. These are the major forms of energy we have. We have to define these forms of energy one after the other. First, definition of mechanical energy. Mechanical energy is the energy of motion. It is the form of energy possessed by moving objects as well as machines and all machinery. We have two main types of mechanical energy. One is kinetic energy, the second one is potential energy. Kinetic energy is energy possessed by a body that is in motion. Example, moving vehicle, aeroplane or helicopter in motion, or any object that is falling, including birds. Potential energy, on the other hand, is energy possessed by a body due to its position or level. Such energy is not, it is a stored energy. It is energy possessed by a body that is not yet in motion but is ready to move if it is allowed to. Example, a piece of stone in a stretch catapult or an object held up in the sky. If you put a piece of stone in a catapult, before you stretch it, that stone cannot shoot out. It does not possess any energy that will make it to shoot out. But as soon as you stretch the catapult with that stone, it possesses energy, because with that, if you allow that stone, it will shoot out, but it's not yet moving. Likewise, any object, a piece of stone that is held up in the sky, it is not moving, it is not falling yet, but once you release it, it will start falling because it possesses energy that will enable it to fall. Chemical energy. Chemical energy is the energy stored in molecules of food and fuel. Any chemical that is used by machines like electric generator, motor vehicle, it stores chemical energy, and that energy enables the vehicle to operate, to move. The food you eat contains chemical energy that gives you energy to do your work, to move, to run, and do other work. So food and fuel store chemical energy. Remember that fuel is any object, any substance that burns and releases useful heat energy. Example, petrol, kerosene, diesel, charcoal, coal, even firewood. All these are fuel because they are used when they are ignited, they burn and release useful heat, which we use to cook and to perform other operations involving chemicals. Then heat energy. Heat energy is got from burning fuel, and also energy we get from electricity. We also get heat energy from the sun as one of the forms of energy of the solar energy, sources of from the sources of heat energy. Then any material we say that can burn and release heat energy is referred to as fuel. I've already given you examples. So if you go to some filling station, they write no fuel, kerosene, yes. Maybe they don't know that kerosene is fuel. So the important thing is that any substance that burns and releases heat energy is referred to as fuel. Then all these are used to generate heat when they are ignited. Now, electrical energy. Electrical energy is a form of energy got from electricity. It is used in operating electrical and electronic appliances like electric iron, electric cooker, television, and radio, etc. Then light energy is the energy got from light sources and they enable us to see, and it is used to operate light-dependent appliances and also used by plants to manufacture their food by photosynthesis. Nuclear energy. Nuclear energy is the enormous heat energy got by splitting atoms of some elements like uranium. Nuclear energy can be used in generating electricity and also for production of nuclear weapons. Sound energy. Sound energy is the energy we get from vibrating objects. They enable us to hear, listen to sounds. Other forms of energy. We have the following forms of energy that are dependent on the major forms, like solar energy. Energy from the sun is called solar energy. It reaches us in form of heat and light. Water energy, otherwise called hydro energy, is energy got from flowing water, example river or ocean. Wind energy is the energy from the wind. It is useful in some places for operating machines like windmill. Power. Power is the rate of use of energy. We also define it as the rate of doing work. We have two types of power. We have mechanical power and electrical power. Mechanical power is the rate at which mechanical work is done. It is given as power equals work done over time taken. Electrical power is the rate at which electrical work is done. The formula for electrical power is P power equals current times voltage. That is P for power, I for current, and V for voltage. So P equals IV. That is current times voltage. Other formula for electrical power as derived from Ohm's law. According to Ohm's law, we have current. The formula current equals voltage over resistance. That is I equals V over R. Voltage is equal to current times resistance. That is V equals IR. And the resistance R is equal to voltage over current. That is V over I. Therefore, by substituting IR for V and V over R for I, we have the following formula for electrical power. 1. P equals I squared R. Because P is equal to IV, if you substitute V, if you substitute IR for V, that is, remove V and put IR, you have the formula P equals I times IR. That will give you I squared R. The second one, P equals V squared over R, is got by substituting by substituting V over R for I. That is, if you remove I, you put V over R. The formula P equals IV will now be P equals V over R times V. That will give you V squared over R. Units of measurement. Energy is measured in the unit called joule, J for abbreviation, and kilojoule for higher unit. Work is also measured in joule and kilojoule. Force is measured in Newton and kilonewton when you have higher measurements. Then power is measured in watts and kilowatts. Current I is measured in ampere or amp for short. Voltage is measured in volts. Resistance is measured in ohms. These are the units of measurement which we will make use of in our calculations. Then we have to go into calculation involving energy, work, and power. We use the following examples to do the calculations. Example 1. If you are given that a force of 10 Newton was applied to lift a load through a distance of 3 meters, calculate work done. In solving this, you first of all write the formula. Work done equals force times distance, which is equal to 10 Newton, force of 10 Newton times distance of 3 meters. That will give you 10 times 3, 30, and the unit of force, the unit of work is joule. So 30 joule is your answer. Then we have what we call acceleration due to gravity. Suppose you are given a calculation that does not involve force. Rather, you are given the weight of a body and asked to calculate work done involving that weight. You cannot find, you are not given force, but you can convert that weight, which is in kilogram, you convert it to force by multiplying it by what you call acceleration due to gravity. It is a constant value, 10 meters per second squared. So if you are given the weight of a body that is to be lifted or to be pushed, you have to convert it to force by multiplying by 10 meters per second squared. With this, you calculate the force applied in lifting the load. We look into some examples. We take example number 2. Calculate work done in lifting a bag of cement weighing 50 kg through a distance of 5 meters. Acceleration due to gravity is given as 10 meters per second squared. In solving this, you write the formula work done, W equals force times distance, which will give you first of all calculate the force, because you are not given the force, rather you are given the weight. So you convert that 50 kg to force by multiplying it by 10 meters per second squared. That will give you 50 kg times 10 meters per second squared, which will give you 500 Newton. You have now converted it to force. Then distance given is 5 meters. Therefore, the work done will be equal to 500 Newton times 5 meters. That will give you 2,500 joule. This 2,500 joule, you can convert it to a higher unit, to kilojoule, by dividing it by 1,000, because 1000 joule gives you 1 kilojoule. Therefore, 2500 joule, to convert it to kilojoule, you divide by 1000. That will give you 2.5 kilojoule. Answer. Then example 3, you are required to calculate the mechanical power consumed in doing a work of 200 joule in 10 seconds. Here you are required to calculate mechanical power, which formula is P power equals work divided by time. The work done is 200 joule divided by 10 seconds, the time taken. That will give you 20 watts. We have example number 4. Calculate the power consumed by an electrical appliance of voltage 12 volts when a current of 3 amperes flows through it. In solving this, you use the formula P equals IV. That is the first formula of power. That will give you I is current, which is 3 amperes. V is voltage, which is 12 volts. P, therefore, is equal to current times voltage, which is 3 times 12. 3 amperes and 12 volts. That will give you 36 watts. Remember, watts is the unit of power. Then, suppose you are given an example that does not involve voltage or current. That is where you apply the other formula for power. For example, example number 5, you are required to calculate power consumed by an electrical appliance of resistance 4 ohms if the current I in the circuit is 2 amperes. Here you cannot use the formula P equals IV. Rather, you use the second formula P equals I squared R, because you are not given voltage, but you are given current and the resistance. And using P equals I squared R, you have 2 squared, because current is of 2 amperes. You square it, 10 times the resistance of 4 ohms. That will give you 2 squared times 4, which is 4 times 4, 16 watts. Evaluation. In conclusion, my dear students, you are required to answer the following questions. Number 1, define A, energy, B, work, C, power. Number 2, what are the units of measurement of energy, work, force, and power? Number 3, list the major forms of energy. Number 4, define chemical energy, heat energy, and nuclear energy. Number 5, calculate work done if a force of 20 Newton is applied to move a stone through a distance of 5 meters. Number 6, calculate power, that is electrical power, when voltage is given as 12 volts and resistance 4 ohms. Remember to write formula before solving any one. You can reach me if you have any question, and if you are submitting your answers to the questions and the assignment, you can reach me through my WhatsApp number 0803 749 3839. Thank you, my dear students.